Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
Hello everyone. In today's class, we are going to discuss the basics of inductor and capacitor, their series and parallel connections. Let us understand what an inductor is. Now basically inductor is an element which converts electrical energy into magnetic energy, and it converts electrical energy into magnetic energy when current is made to flow through it. Okay, the symbol is shown and the series connection is also shown. Now we know how a series connection looks like and how a parallel connection looks like. Now when you talk about the series and parallel connection of an inductor, the relationship is exactly same as that of a resistor. So series equivalent inductance is again the sum of all individual inductance. So I can say that total inductance LS, S signifies series, so LS is equal to L1 plus L2, and similarly in parallel connection again the relationship is same as that of the resistor. So here also I can say that LP, P stands for parallel, so LP is L1 L2 upon L1 plus L2. Now let us understand what is the meaning of inductive reactance. Now if you have a resistor, the property of a resistor to oppose the current is called resistance. Now similarly inductor also opposes the current. Fine, so that property is known as reactance. So in simple words I can say that inductive reactance is nothing but resistance offered by an inductor. Now how do we represent it? So reactance is represented by letter X, and since it is inductive reactance we give a subscript L. So XL stands for inductive reactance. Now inductive reactance is represented as omega L. Omega is the angular frequency in radians, so which is given by 2 pi f. So finally I can say that inductive reactance XL is equal to 2 pi FL. Now 2 is constant, pi is constant, and for a given circuit L is also constant, right? So I can conclude that X is proportional to F, particularly XL. Inductive reactance is proportional to F. It means that the opposition is proportional to the frequency, right? It means that if any signal is applied through an inductor, if the frequency is less, the opposition will be less, and if the frequency is more, opposition is more. Now what is the frequency for DC? In the beginning itself I told you that it is 0. So what is the opposition offered by an inductor for DC? Obviously it is going to be 0. So I can say that inductor allows DC. Now what is the frequency of AC? It can be anything but a non-zero value. It means that it opposes AC, right? Because it is giving some opposition to AC. So basically you have to remember that inductor allows DC to pass through it and it opposes AC. Now let us see how a capacitor behaves, right? So basically capacitor is an element which stores the electrical energy in the form of charges, and the SI unit of inductance was Henry and SI unit of capacitance is Farad. Symbol is shown and the series and parallel connections are also shown. But here you have to remember that in series and in parallel the equations are exactly opposite to that of an inductor or a resistor. Now in case of inductor and a resistor, series combination was represented by R1 plus R2 or L1 plus L2, whereas in the case of capacitor, parallel combination is represented by C1 plus C2 and series combination is represented as C1 C2 upon C1 plus C2. Fine. This we have to remember. Now next talk about capacitive reactance. Now in the similar fashion, capacitive reactance is the opposition which is offered by the capacitor. Fine. So I can say that it is nothing but, in of course simple language, I can say that capacitive reactance is nothing but the resistance offered by the capacitance. Fine. Now here reactance is again represented by X and subscript C is used to denote capacitance. So capacitive reactance is represented by XC, and it is given by 1 upon omega C. Fine. In case of inductor, it was omega L, but here it is 1 by omega C. So it says that X is equal to 1 upon 2 pi FC, because omega is 2 pi F, right? So I can conclude that capacitive reactance is inversely proportional to frequency. Now, what does that mean? It means that if frequency is more, the capacitive reactance will be less, and if the frequency is less, capacitive reactance will be more. Now, what is the frequency of DC? The frequency of DC is 0. So what is 1 by 0? It is infinity. So I can say that capacitor opposes or blocks DC. Why blocks? Because it is offering infinite resistance. So I can say that capacitor opposes DC. So it does not allow DC to pass through it. But for AC, in household supply, the frequency is 50 Hertz, but it can go to any value depending on the application. It can go to megahertz, gigahertz, terahertz, right? So whatever is the frequency, the capacitive reactance will be inversely proportional to frequency. Fine. So it means that it allows AC, but it blocks DC. Okay.